All right, so the math dealer here, and today we're going to look at finding implicit differentiation. Okay, so basically you're like, what the heck is that? Basically what we're doing is we're finding derivatives, right? We're going to find derivatives because we see the differentiation, so you got that going for you. But we're basically finding derivatives of relations, okay? So they don't have to be functions because we know there are curves that, by the way, are not functions, right? We know parabolas on their sides. We know circles. We know hyperbolas, all kinds of things that are not they're not functions. They are relations, but they're not functions. Okay, so let's get started. Key thing you want to remember when you're doing implicit differentiation is that every time you say to yourself, hey self, I need to find the derivative of a y, you must multiply it by dy dx. That's the chain rule working on the derivative of y. Okay, so what are we saying? Basically, go ahead and kick out the derivative like you normally would have done. Derivative of x, 1. You got that. Derivative of 3, 0. You've seen pictures, right? You don't even have to write 0, but since it's a lesson, I might as well write it, right? Derivative of y squared. Now, let's talk about that. That's 2y based on the power rule. But then you have to remember to multiply it by the inside derivative, which is dy dx. So you are multiplying it by y prime, also known as dy dx. Okay, now just get dy dx by itself. Well, you can do that. That's a little algebra action, right? You're like, okay, well, I have a 1. I'm going to divide both sides by 2y. You've seen pictures. This 0 is useless to me. I shouldn't say useless, but you know what I mean. So I get 1 over 2y. Now, here's a little fun fact. If we had to find the second derivative, okay, so I'm going to find the second derivative now. All right, using the same function. Okay, well, we can do this right now. I could actually rewrite this as 2y to the negative first power. Okay, by doing that, it actually makes this a little bit easier to find the derivative. So the negative 1 comes down in front. Bam! Took a lot of effort to get down in front. You've heard that before. Now I have to take the inside derivative of 2y. Well, the derivative of 2y is 2y prime. And remember, y prime is a fancy way of saying dy dx. Okay, so what does this mean for our derivative? Our second derivative, I should say. Well, that means that the second derivative, by the way, let me try to get this a little bit neater, is going to be negative 1 over 2y quantity squared, right, times 2 times y prime. But you're like, wait a minute, y prime is 1 over 2y. So we got that going for us. So then when I clean this guy up, I end up getting negative 2 over 2y quantity cubed. Fun to say at parties, all right? Or I could call this negative 2 over 8y cubed, which, oh, by the way, of course, yes, you're right. That would be negative 1 over 4y cubed. Oh my God, look at me running out of room down there. That's craziness. I know. Let me slide it up. Very fun. Okay, so what did we just found? We found that the first derivative, dy dx, is equal to 1 over 2y. And if I asked you to find the second derivative, or not just me, your calc teacher, right, then you would basically get negative 1 over 4y cubed in its simplest form. Okay, I truly hope that makes sense. Okay, so now let's look at the next guy. I have x squared plus y squared equals 2. So we're just going to find the derivative. Hopefully you're looking at this and going, oh yeah, that's a product rule in action. Okay, and the reason why, by the way, that this is not a function is because for every x, you're actually going to get 2 values of y. I know, right? What the heck is she talking about algebra right now? Yep, it happens. Okay, derivative of the first times the second plus the derivative of the second, which is 2y, y prime, also known as dy dx, right, times the first. And of course, derivative of 2 is just 0. So now your mission, not a tough mission, just a mission that needs to be accomplished. Let's get this guy by itself. To get the 2 dy dx by itself, I first need to bring over 2x squared. Now look what I'm going to do. I am actually going to write out steps. What the heck is Diehler doing? I know, right? What the craziness, right? So I take this, slide it to the other side. Then I'm going to divide by the coefficient, which is 2yx squared. So I end up getting, let's go with green, a little Christmassy, I know, right? 'Tis the season, fa la la, right? The 2's cancel, right? And then actually negative xy squared over yx squared becomes negative y over x, okay? That is the derivative of x squared y squared equaling 2. It's a derivative of that function, Okay. Now, if they asked you to find the second derivative, you would do it all again. Okay. And this time, once again, it's a quotient rule. Okay. So this one I probably would keep in the quotient rule and just kick this out. All right. All right. Let's slide one more up here. Look at this little cosine, little trig function. I know. So exciting. All right. Here we go. We're going to find the derivative. That's going to be 1, because derivative of x is 1, plus y prime, right? Because the derivative of y is dy dx. Then I'm taking the derivative of cosine, which you all know and love to be negative sine y. And if I have you in class, I always say, do not change the argument. But you do need to find the derivative of y, which, oh, by the way, is dy dx. Now, I have dy dx on both sides of this equation. So let's group them together, all right? Which means I'm going to take this entire term that has dy dx in it and slide it over. Then at the same time, I'm going to take the 1 and move it to the other side. So that's going to leave me with dy dx plus sine y dy dx equals -1. Now pause the video. Make sure you know where I just got all this expression from, right? Where I got this expression from. Okay? Now, factor out the dy dx. We can do that. You've seen pictures. When I do that, I'm left with 1 plus sine y equaling -1. Now, I tell you, the one that messes people up is when you factor dy dx out of dy dx, you're left with a 1. I can't tell you how many of my students will put 0 sometimes, and I'll be like, "Whoa!" Right? Remember, dy dx divided by dy dx is 1. So that's going to leave me with dy dx equaling -1 over 1 plus the sine y. And that is the derivative of x plus y equals cosine y. All right, this is the math dealer signing out. Hope this was helpful.